Inside every arcade game, there is a darkness. And in that darkness, there is a button. A button that holds the power over a whole universe.
Welcome to another Beyond the Woods devlog, a software-side look at building an indie arcade game with the Godot engine. Today we look at the test mode. To anyone not familiar with arcade machines, there's a configuration screen which allows the operator to access a wide range of settings for the game. This is called the test mode. Typically, the test mode will include things like pricing, game difficulty, number of lives, as well as cabinet options like sound volume, attract mode options, and troubleshooting tools. Inside the machine, there is a button or switch to activate the test mode, but on older games, the settings were activated with dip switches. Beyond the Woods will be running on our demo unit in the near future, so having our test mode implemented is a top priority. Check out that project on our YouTube channel if you are interested. Let's have a look at the editor. Our global singleton looks for input from our test button and coin switches on every frame. It is important that the game always reacts to these events regardless of what else is happening. The test mode will preempt any other game functions, ending them and entering the test scene. At this point, I'm really only focused on building out the options necessary for my demo station, so there are only the credit options and the restore defaults option currently available. On the left is the main menu, which is an HBox container holding a column of button nodes set up with toggle mode enabled. On the right is a plethora of nested containers that hold the options for each of the main menu items. Each button has an animation player child node that makes it blink when focused. When a setting is changed, each button's script writes the change to an external settings.cfg file. Toggling the free play button saves a Boolean value that will be loaded by the game on startup. This will allow players to start the game without payment. The tender type radio buttons and the credit value settings don't affect gameplay, but are there for the operator's bookkeeping convenience. This functionality will be added in the future. The tender units per credit settings determine the cost of gameplay. On pressing the Restore Defaults button, the Confirmation button is focused. Pressing this button restores all of the default values in the test mode. Feedback is given by a label made visible with the timer node. The message disappears in 3 seconds. Here's an interesting coding tidbit I came across while building the Restore Defaults section. So each of the defaults is stored in each button's script as a constant. Each button is buried in container boxes several layers deep. So in order to tell the button to load its default value, I either needed to hardcode the path to each button node, or be able to iterate through the entire tree of containers. So I went with the latter. The problem, though, is that the getChildren method only goes 1 layer deep, so I created a function that recursively calls getChildren until it hits bottom. This may be useful to others for other situations. It's a bit ham-fisted, and you wouldn't want to call this function every frame because it's expensive, but for something as infrequent as restoring default settings, it's fine. Once all the configuration is complete, you press the test button again and the game resets. The global singleton loads the new settings and stores them in the relevant variables on startup. It works! If you like this video, thumb us up, and consider subscribing if you'd like to keep up on this project or others at Vagabond Arcade. Thank you for watching, and be well.